Okay, so this example I'm going to do right here is the one I was hoping to get to in the last part of the notes from day one. So that's where this example is coming from. If we got through that problem, that's great. If not, here is the video that explains it. Or if you need a little further explanation, here is also something that might be helpful. So here we have that list of things we have to find. This is the list you're going to need to be comfortable with and being able to find things like that. So again, just to review here, the domain is the exclusions when the denominator is 0. We write it in interval notation, and we do the domain before simplifying the problem. The range, we do this last after we've graphed with all of the asymptotes, and once again, we write this in interval notation. Our x-intercepts, these are vocabulary that we've already known from previous sections. It's the value of x when y equals 0, and it's an ordered pair. So essentially, we're just going to put 0 in for y and solve for x. If we are looking for the y-intercepts, that's where it crosses the y-axis. It's going to be an ordered pair, and it's the ordered pair when x equals 0. So we're going to put 0 in for x and go ahead and calculate that. The asymptotes, that's a little bit more difficult. The vertical asymptotes relate right back up to the domain. So they are the exclusions from the domain after simplifying, and vertical asymptotes are always written in the form of x equals because they're a vertical line. So horizontal asymptotes, this is one you have to think about just a little bit. You have to look at the degree of the numerator and the denominator. If the degree of the numerator and the denominator are the same, then your horizontal asymptote will be at y equals a over b, where a is the lead coefficient of the numerator and b is the lead coefficient of the denominator. Or if the denominator is larger, the degree of the denominator is larger than the degree of the numerator, then it's always going to be y equals 0. Okay? And then a slant asymptote happens when the degree is less than, the denominator is less than the numerator. So these two are related here, right? So if the degree is equal, then that means the degree is equal, that means there'll be a horizontal asymptote. If the degree in the denominator is greater, it's going to be a horizontal asymptote. If the degree in the denominator is less than, we have to use synthetic division, whoops daisies, and we are not going to do that until tomorrow. So we will not actually have any slant asymptotes today where we have to use polynomial division to find the equation of the line. And then the last thing is our wholes. Again, we did notes on all of this yesterday, so I'm going through this fairly quickly. The wholes are the values where the numerator and the denominator have a common factor. And I believe that this example that we are going to do here actually has a whole in it. Okay, so let's go ahead and look at what we have here. We have x squared plus x minus 2 divided by x squared minus x minus 6. Let's go ahead and factor both of those. Again, you're going to need to become pretty good at factoring in this section. So far, everything that we've had has had a lead coefficient of 1, so that makes everything a little bit easier. So if they need to multiply together to be negative 2, add together to be 1, that would give us x plus 2 and x minus 1. And then in the denominator, if they have to multiply together to be negative 6, add together to be negative 1, we would have x minus 3 and x plus 2. So the first thing that we do is we figure out what our domain is, and we do that by figuring out what x can't be. Well, x can't be 3, and x can't be negative 2. So again, I like to think sometimes it helps to think about this on a number line. Okay, so on a number line, if we had negative 2, negative 1, 0, 1, 2, 3. I'm telling you that it can't be negative 2 and it can't be positive 3. However, it can be everything else, which means if we start at negative infinity, which is here, negative infinity and positive infinity. If we start at negative infinity, we are going to go to negative 2 and stop. We're going to jump over it. So we're going to have our union symbol there. And then we are going to start at negative 2 again, go until we hit 3, stop, jump over, and then we're going to go from 3 to infinity. Okay, so we have 3 sections of the graph. Again, our range, we will come back to that guy. when we're all done and we have everything all graphed with our asymptotes. So let's go ahead and look and see if there's anything that we can simplify. Now that we found our domain, we can go ahead and simplify and use that easier simplified expression to do the rest of the problem. So if you notice, we've got an x plus 2. We can take both those guys out, and we are only left with x minus 1 and x minus 3. Okay, so let's go ahead and move on down here. Our x-intercepts are our value of x when y equals 0. So if we have 0 equals x minus 1 over x minus 3, if we think butterfly method, these two guys are always going to multiply and be 0. So we're going to have 0 equals 1 times x minus 1 is just x minus 1. So x equals 1 because we add 1 to both sides. In our ordered pair, remember it's an ordered pair, is going to be 1, comma, 0 because it's the value of x when y equals 0. Okay, so let's go ahead and put that guy on our graph. We're going to be at 1, 0 down here, which is right here. Then let's look at our y-intercept. Again, our y-intercept is the value of y when x equals 0. So we're going to have y equals, and we're just going to use that simplified equation, 0 minus 1 over 0 minus 3, which equals 1/3. So our y-intercept is going to be at 0, 1/3. So let's put that guy on there. 0, comma 1/3. We're going to be right about here. We're going to be right above that. All right, our vertical asymptote, again, we look back up at our restrictions, which was x equals, can't be 3 or negative 2, but we got rid of that negative 2 because we simplified it out, which means our vertical asymptote is going to be at x equals 3. So that's going to be vertical at x equals 1, 2, 3. So let's there's there's my vertical asymptote. My horizontal asymptote, the degree of the top and the degree of the bottom is the same, which means it's going to be y equals a over b. The lead coefficient in the top is 1. Lead coefficient in the bottom is also 1. So my horizontal asymptote is at y equals 1. So let's go ahead and draw that guy in there. Okay. The slant asymptote, there is none. We haven't talked about any slant asymptotes yet because since we had a horizontal asymptote because the degrees were the same in the top and the bottom, we can't have a slant asymptote. So the holes, remember the holes were where we took a factor out at the top and the bottom. We took a factor out at x plus 2, which means x equals negative 2, because again, if we set it equal to 0, x equals negative 2 is going to be where our hole actually is. So if you needed to use your graphing calculator to see where the branches or anything are, that is just fine. We are going to have a branch here, and we are going to have a branch that goes through our y-intercept, through our x-intercept, like so. However, we have a hole at negative 2, so we find negative 2 on our graph, and we have a hole at negative 2. So really, again, for whatever reason, it doesn't like to erase my red that I have written there, but we would have a hole at negative 2 on our graph. Okay, and then the last thing we do that we can't forget about is we go back up and we do our range. Remember, our range was up here, we do at the very end. And our range is we read it from the bottom to the top. So our graph starts at negative infinity, goes up to positive 1, stops at 1, and then goes on to positive infinity. So our graph is going to go, its range, the range is going to go from negative infinity to 1, and also from 1 to positive infinity. Okay, so that example there is either we did it in class yesterday and here's another explanation of it, or we didn't quite get to it, so here's an explanation for you on how to help you do it. The next problem on the class kick should be fairly similar to this.